So imagine it is the middle of June 2026.
Okay.
The technology markets are just in an absolute frenzy. I mean, OpenAI has just confidentially filed for an IPO.
Which is huge.
Yeah, exactly. It kicks off this massive race to Wall Street. And artificial intelligence systems, specifically these autonomous AI agents, they're now writing enterprise-grade software code essentially for free.
Right. Which completely changes the math for everyone.
It really does. The barrier to entry for building a tech company has hit absolute zero. Everyone is predicting this like trillion-dollar boom in wealth generation. So if you were to guess where the epicenter of this massive technological revolution is, what would you picture?
Oh, the usual. A gleaming glass-walled campus in Silicon Valley.
Right, or maybe a hyper-modern skyscraper in Shenzhen.
Sure.
But what if I told you that one of the most ambitious blueprints for this new era is actually situated in a dusty residential duplex in Midland, Texas?
A duplex.
A single duplex, and it's funded entirely by money pulled from the oil beneath the dirt.
It's just such a jarring contrast, isn't it?
Totally.
I mean, we are looking at a scenario where the bleeding edge of global technology, virtual reality, autonomous robotics, agentic AI, all of that is being anchored in one of the most traditional, resource-heavy, and honestly unforgiving geographic environments on the planet.
And welcome to the deep dive. That contrast, that is our mission today. We are exploring how an entrenched legacy industry region can just completely reinvent its economic DNA.
It's a fascinating pivot.
It really is. And the source material we are unpacking today is this incredibly dense blog post dated June 10th, 2026. It's from a site called Netizen, authored by someone named Paramendra.
Right.
And the entire focus of this post is a radical, comprehensive blueprint for Midland, Texas, which is right in the heart of the Permian Basin.
Okay, let's unpack this because this isn't just a dry business analysis.
No, not at all. And for anyone listening right now, whether you manage a business, lead a team, or you're just trying to navigate career shifts in this rapidly changing economy, this blueprint is a masterclass in the mechanics of diversification. Yeah, it really flips the script.
It challenges the standard playbook entirely. Usually, when a legacy industry tries to modernize, it just attempts to mimic tech hubs.
Like, let's build a shiny innovation center and hope tech startups magically move here.
Exactly. But this document proposes the exact opposite. It suggests looking at your immediate environment, identifying your absolute worst liabilities.
Which, in Midland's case, is an incredibly harsh, water-starved climate.
Yes, and highly dangerous industrial work environments. You take those exact liabilities and you engineer a way to turn them into your most valuable, globally exportable products.
I want to dig straight into how they actually plan to do that, because the first major proposal in this blueprint tackles the danger aspect head-on.
The safety app.
Right. The author proposes building a world-class safety application specifically for the oil industry, born right there in the Permian Basin. But I gotta be honest, my initial thought when reading the phrase safety app was, frankly, a digital checklist.
A PDF on an iPad.
Exactly, like something a site manager just taps through to appease corporate compliance.
Yeah, and that is the traditional model, which treats safety as an administrative burden, like a cost center.
Right.
But the blueprint envisions something entirely different. It's a centralized, cross-company technological platform. We are talking integrated, augmented reality, dense sensor networks, and real-time biometric tracking.
It's treating safety like an engineering problem.
Exactly. An engineering problem to be solved with heavy software and hardware integration.
So let's break down the mechanics of this, starting with the training protocol, because the author advocates for a massive pivot away from traditional classroom training.
No more sitting in a stuffy portable trailer.
Right, watching those 20-year-old safety videos where the acting is just terrible.
The worst.
Instead, they propose hyper-realistic, immersive AR, VR, and XR training. Augmented, virtual, and extended reality.
The neurological implications of that shift are profound, honestly.
How so?
Well, when you watch a video of a catastrophic blowout on a drilling rig, your brain categorizes it as passive information. You're just observing a distant event.
You're safe in a chair.
Exactly.
Yeah.
But when you put on a virtual reality headset, and the audiovisual environment tricks your sensory inputs into believing you're actually standing on the rig floor as a high-pressure line bursts.
Oh, wow.
Your brain's amygdala engages. You experience genuine physiological stress. So the learning process moves from passive memorization to active experiential memory formation.
And the document makes a critical distinction here that I think elevates it beyond just, a sophisticated video game. The trainees aren't just holding plastic controllers in an empty room.
Right, the AR overlay.
Yeah, the proposal specifies the use of augmented reality overlays on actual physical equipment. So a trainee is physically turning the heavy metal valves. They're feeling the resistance, sensing the tactile reality of the machinery.
While the AR headset is projecting the visual and auditory chaos of an emergency scenario all around them.
It's wild.
But that tactile integration is what builds true muscle memory.
Which is what you need.
Exactly.
Right.
Because in a crisis, higher order cognitive function often just degrades due to panic. You fall back on instinct and muscle memory.
And if your only training was clicking through a multiple choice quiz on a screen, you have no physical instinct to fall back on.
None at all. By combining the physical hardware of the rig with the digital overlay of the crisis, the worker's hands learn exactly what to do when the alarms start sounding.
Okay, so that prepares the human. But the blueprint goes much further. It tries to eliminate the human error equation altogether by deploying dense IoT networks.
Internet of Things.
Right. We are talking about blanketing the entire well site with sensors, both above ground on the equipment and deep underground in the well bore itself.
The sheer volume of data generation here is staggering. I mean, these aren't just simple temperature gauges.
What are we talking about?
We are talking about acoustic sensors. They literally listen for the microscopic high-frequency pings of metal fatiguing under stress.
Wow.
Yeah, and thermal imaging, chemical sniffers detecting ambient gas anomalies at like parts per billion ratios.
Yeah.
And continuous structural integrity monitoring.
See, I'm trying to picture the bandwidth required for that, because these oil fields are incredibly remote. How are they moving gigabytes of raw sensor data out of the West Texas desert in real time?
Well, that requires localized edge computing. You really can't pipe all that raw data to a cloud server in Virginia.
The latency would be terrible.
Too high, yeah. And the connectivity in remote basins is just too fragile. So the computing power has to sit on the edge, right there on the rig.
Oh, I see.
The AI models run locally. They digest the millions of data points a second. And they only ping the central network when an anomaly breaches a critical threshold.
It makes me think of the evolution of the smart home, honestly, but scaled up to industrial extremes.
How do you mean?
Like in a basic smart home, a smoke detector just makes a loud noise, and it's up to you to hear it and call the fire department.
Right.
But a hyper-advanced system detects the specific chemical signature of an electrical fire, shuts off the power to that room, unlocks the front door, and transmits the floor plan to the fire department before you even wake up.
That's a great analogy.
Thanks. It just seems to be the philosophy here, transitioning the entire oil field from a reactive posture to a proactive, autonomous safety posture.
And that smart home analogy holds up perfectly when you look at the third pillar of this proposed platform, which involves advanced first aid and emergency response integration.
The wearables.
Yes, the blueprint details outfitting every worker with wearable biometric sensors.
So like smartwatches on steroids.
Oh, far beyond consumer smartwatches.
Yeah.
These would monitor core body temperature to prevent heat stroke, which is a massive issue in the Permian summer.
Oh, for sure.
Along with heart rate variability, blood oxygen saturation, and impact detection. So if an incident does occur, say a worker falls or is struck by equipment, the wearable instantly triggers an alert.
And the source notes that this data, like the worker's exact geolocation on the massive site, their real-time vital signs, and the estimated force of the impact, it's transmitted directly to local trauma centers. That blew my mind. The trauma surgeons have a real-time feed of the patient's deteriorating vitals before the ambulance has even pulled out of the hospital bay.
Well, in emergency medicine, they operate on the concept of the golden hour.
Right. The critical 60 minutes.
Exactly. The 60 minutes following major trauma where medical intervention has the highest probability of saving a life. By feeding biometric data directly to the trauma team, they can prepare the operating theater, pull the specific blood type, and brief the surgical staff while the patient is still in transit.
You are literally buying back minutes of that golden hour through data latency reduction.
Exactly.
It is a brilliant application of the technology. But we have to look at the financial reality here.
The cost.
Yeah, outfitting thousands of remote workers with military-grade biometric wearables, blanketing hundreds of square miles of desert with acoustic and chemical sensors, developing bespoke AR software. I mean, the capital expenditure for this would be astronomical.
Very true.
No single software startup could afford to build this on speculation.
But the funding model is where the author's strategy reveals a deep understanding of corporate incentives. What's fascinating here is that the proposal points out that major operators, companies like ExxonMobil, Chevron, Pioneer, ConocoPhillips, they already maintain massive operational footprints in the Midland area.
Right.
And every single one of those corporations spends billions of dollars annually on safety compliance, insurance premiums, workers' compensation, and lost time incidents.
Safety is a massive, mandatory sunk cost for them.
Exactly. So the idea isn't to ask venture capitalists in Silicon Valley to fund this app. The idea is to tap the existing, localized corporate budgets.
Oh, okay.
The author proposes a consortium-funded development model. You convince these fierce competitors to pool a fraction of their existing safety budgets to jointly fund the development of this single centralized platform.
Okay, I have to pause on that because the corporate culture of major oil operators is intensely competitive and highly secretive. Getting Exxon and Chevron to share the same digital platform and pool their proprietary safety data seems like a bureaucratic nightmare. Why would they ever agree to that?
Well, they would agree to it because safety data is uniquely positioned outside the realm of competitive advantage.
What do you mean?
If Chevron discovers a faster way to drill through shale, they will protect that intellectual property fiercely because it lowers their cost of production relative to Exxon.
Makes sense.
But if an operator discovers that a specific type of valve fails catastrophically under certain pressure conditions, keeping that a secret doesn't give them a market advantage. It just ensures someone at a competitor site gets hurt.
Wow. Okay, yeah.
In fact, standardizing safety protocols across the region lowers the overall insurance risk profile for the entire basin.
That makes perfect sense. If everyone uses the same hyper-advanced early warning system, the entire ecosystem becomes less volatile. And the blueprint mentions anonymizing the incident sharing on the real-time dashboards, so they are learning from each other's near misses without exposing their operational vulnerabilities.
Precisely.
But there is a larger endgame here, isn't there? This isn't just about making the Permian Basin safer. It's about creating a product.
It is about creating globally exportable intellectual property. The logic is simple. If you can engineer a hardware and software ecosystem that successfully operates in the 110-degree heat, dust storms, and hazardous environments of the Permian Basin.
You have built a system that is fundamentally battle-tested.
Yes, it is a ruggedized technology platform.
And once it works there, you package it and sell it. The author lists North Dakota's Bakken Formation, complex offshore rigs in the Gulf of Mexico, and operations in the Middle East.
And it easily jumps the boundary of the oil and gas industry.
Really? Where else?
An IoT network designed to monitor metal fatigue, ambient gas, and worker vitals in an oil field can be directly integrated into massive open-pit mining operations in Australia, or complex chemical manufacturing plants in Germany, or heavy construction sites globally.
So Midland transforms from a place that just sells barrels of oil, a physical commodity subject to massive price swings, into a place that sells enterprise-grade software licenses and hardware subscriptions.
Right.
They become a global SaaS provider for industrial safety.
By utilizing the capital and the harsh conditions of their legacy industry, they fund their own diversification into the technology sector. It is incredibly pragmatic.
It really is. But as we pivot to the second major section of Paramedra's blueprint, things take a turn that I found genuinely surprising.
The agriculture pivot.
Yes, because the author takes the exact same technological framework we just discussed, the dense sensor arrays, the real-time data analytics, the autonomous systems, and applies it to a completely different sector. We move from industrial oil field safety to plants, specifically the high-tech farming of cactus.
The transition feels disjointed at first glance, I know, from steel pipes to plants. But structurally, if we connect this to the bigger picture, it is the exact same play, turning a regional liability into a global asset.
Okay, let's set the stage here. The crop in question is the prickly pear cactus, scientifically known as Opuntia ficus indica.
A very resilient plant.
Unbelievably resilient, because the Permian Basin is a desert. It is incredibly arid, water is a precious and scarce resource, and the summer sun is punishing. Traditional agriculture, like growing cotton or wheat, is incredibly resource-intensive and increasingly difficult as aquifers deplete.
Sure.
But the prickly pear thrives in this exact environment. The source notes that these specific cactus varieties can produce massive amounts of biomass while using up to 80% less water than conventional crops.
And the biology behind that water efficiency is fascinating.
Break that down for us.
Well, most plants open their stomata, the pores in their leaves, during the day to take in carbon dioxide for photosynthesis.
Okay.
But that causes them to lose massive amounts of water through transpiration in the hot sun.
Like sweating.
Exactly.
Hmm.
The prickly pear uses a different mechanism called CAM photosynthesis.
Cam.
Yes. It only opens its pores at night when it is cool. It stores the carbon dioxide as an acid and then uses the sunlight during the day to photosynthesize while its pores are sealed tight against the heat.
Oh, wow. That is brilliant.
It is an evolutionary masterpiece of drought tolerance.
Oh.
Furthermore, the massive root systems and biomass act as a highly effective carbon sink, pulling CO2 out of the atmosphere.
The environmental benefits are crystal clear, but the blueprint outlines an economic yield from this single plant that is surprisingly diverse.
Multiple revenue streams.
Huge ones. It lists the edible cactus pads, the nopales, and the fruit, the tunas, which have massive markets in human food and beverage. It provides livestock fodder, which is vital in drought-stricken ranching areas. It can be refined into cosmetics, nutraceuticals, biomaterials, and organic fertilizer.
And perhaps most critically, for an energy-focused region, the raw feedstock can be converted into biofuel and biogas.
Okay, here's where it gets really interesting, but I have to challenge this premise.
Go for it.
When the author talks about scaling up biofuel production from a cactus in the desert, I see a massive logistical flaw.
The water.
Yes, the water. Processing biomass into fermentable sugars and then distilling that into biofuel typically requires astronomical amounts of water. You can't just squeeze a cactus and get a gallon of diesel.
Right.
If they are in a water-starved region, where on earth are they getting the water to run an industrial-scale biorefinery?
That is the exact bottleneck that traditionally kills desert agriculture projects. However, the blueprint implies a localized synergy that solves this.
Okay, I'm listening.
The oil and gas extraction process in the Permian produces billions of gallons of what is called produced water.
Produce water.
It's wastewater that comes up from the shale formations along with the oil.
No.
It is highly saline and toxic, completely unusable for traditional crops.
So what good is it?
Well, if you deploy advanced, localized desalination and filtration tech, again, funded by the oil industry's need to dispose of this water safely, you can treat it just enough for industrial fermentation processes.
Oh, I see.
Or even targeted drip irrigation for highly tolerant plants like the prickly pear. Additionally, the cactus itself is comprised of up to 85% water, which can be extracted and recycled during the biomass processing phase.
Wait, really? So they are effectively closing the loop? They take the wastewater liability from the oil field, clean it marginally, and feed it into the biorefinery. That is incredibly clever.
Very.
But even if we solve the water issue, my brain still struggles to associate cactus farming with a tech ecosystem. When I picture this, I just see guys in heavy leather gloves walking through the dust, manually hacking off pieces of cactus with machetes.
Right, it feels very analog.
It feels like low-tech desert survival, just planting succulents in the dirt. How does this fit into a tech ecosystem?
The technology is the invisible layer sitting on top of the soil, underneath the soil, and flying above the fields. The blueprint isn't describing traditional farming at all. It is outlining a blueprint for precision agritech.
Okay.
Remember the dense IoT networks we discussed for the safety app?
Yes, the acoustic and chemical sensors.
You take that exact same architectural philosophy and you point it at the dirt. The proposal involves deploying dense arrays of surface and subsurface IoT sensors across thousands of acres of prickly pear.
But what are they measuring? Not metal stress.
No, these sensors are constantly measuring soil moisture gradients at varying depths. They measure microfluctuations in soil salinity, ambient microclimates, and nutrient uptake rates.
It is the exact same data pipeline, just tracking biology instead of industry.
Exactly. The raw data streams from the soil to the local edge computers. Then, the AI machine learning models take over.
What does the AI do with that?
The AI analyzes historical weather patterns, current moisture levels, and the specific growth stage of the cactus to orchestrate a hyper-precise irrigation system.
Like automated watering.
Better. It delivers a microdose of water to a specific square meter of soil only at the exact moment the plant requires it to maximize biomass yield.
That's insane.
It predicts harvest schedules down to the day. It analyzes drone imagery to detect the early spectral signatures of pest infestations or plant disease, weeks before a human farmer walking the field would ever notice a change in color.
You mentioned drones. The blueprint also specifically calls out the challenge of harvesting.
The gladiates.
Yes, the glachetes, those miserable tiny hair-like spines that embed themselves in your skin. Harvesting thousands of acres of this by hand would be an ergonomic nightmare and massively labor-intensive.
Which is why the proposal leans heavily into automation and robotics. This is where the engineering talent from the Tech Hub comes into play. You need to develop autonomous ground vehicles capable of navigating uneven desert terrain. You need advanced computer vision models integrated into drones that can fly over a plant, identify a ripe piece of fruit versus a developing pad, and map those coordinates.
And then send in robotic harvesters with soft robotic end effectors, basically gentle robotic hands that can pluck the fruit without bruising it while simultaneously avoiding the spines.
Yes.
That requires an insane level of software and hardware integration.
And that is the beauty of this ecosystem approach. The core competencies required to build an autonomous robotic harvester for a cactus farm are nearly identical to the core competencies required to build an autonomous pipeline inspection robot for the safety app.
Oh, I see the overlap now.
Right. You need engineers who understand spatial mapping, computer vision, harsh environment hardware ruggedization, and AI edge computing. The engineering talent, the data scientists, and the localized investor networks can seamlessly cross-pollinate between the industrial safety projects and the AgTech projects.
The economic scale of the author projects for this is just massive. If you deploy this across hundreds of thousands of underutilized acres in the Permian Basin and co-locate these massive high-tech farms with existing solar power arrays, since the desert has plenty of sun, you create an incredibly efficient, multi-billion-dollar closed-loop industrial ecology.
A self-sustaining system.
They are generating clean power, sequestering carbon, producing food, and refining biofuel, all in one region.
But the true macroeconomic value, much like the safety app, lies in the exportability of the intellectual property.
Right, because water scarcity is not just a West Texas problem. It is a rapidly escalating global crisis.
Precisely. If Midland can prove that they have engineered a highly profitable, climate-resilient agricultural system in a punishingly dry environment using AI and robotics, that entire technological package becomes an invaluable export.
Who is buying it?
The blueprint specifically notes that sovereign wealth funds, particularly in the Middle East, North Africa, and regions like Australia, are aggressively seeking investments in sustainable agriculture for arid climates.
Gulf-style sovereign funds.
Exactly. Midland wouldn't just be exporting the biofuel, they would be selling the turnkey software platforms, the robotic patents, and the data models to governments desperate to secure their food and energy independence in a warming world.
It is a stunning pivot. To summarize where we are, we have a life-saving AR/VR industrial app that revolutionizes how the global energy sector handles risk, alongside a multi-billion-dollar AI-driven cactus empire.
These are world-changing, incredibly complex systems.
But where do the people building this actually sit? Which brings us to the third section of the blueprint. And this was the part of the text that really made me laugh.
A physical workspace.
Yeah, because the author's vision for the physical workspace is wildly counterintuitive. If you are building a tech ecosystem aiming to generate billions in global revenue, the standard playbook says you need a monument.
A gleaming campus.
Right. You need a massive, glass-walled campus. You need an architecture firm to design an innovation center that signals to the market, hey, we have arrived.
The author aggressively rejects that vanity metric.
The blueprint outlines the creation of the Midland Tech Incubator. But instead of waiting 3 years and spending $50 million to build a campus, the author suggests starting immediately. And the proposed headquarters: a simple, single residential duplex.
A standard duplex, placed right in the middle of a Midland neighborhood.
I was trying to picture this. A residential duplex just wired to the absolute teeth with gigabit broadband fiber. That is the entire physical footprint.
It sounds absurdly minimal, almost naive, until you view it through the lens of the technological reality of 2026. This duplex is not designed to be a container for hundreds of employees.
What is it then?
It is designed to act as a high-bandwidth router, the connective tissue between local capital and global talent.
Let's break down how this duplex actually functions on a granular level. The first major concept the author emphasizes is globally distributed teams.
Right.
The text argues that the core leadership, the startup founders, the domain experts, and the investor relations teams must physically remain in the Midland duplex. Why is that?
Because that is where the gravity is.
Yeah.
You cannot build an oil field safety app from a coffee shop in Brooklyn.
Fair point.
You need to be able to drive 30 minutes, put on steel-toed boots, and stand on the actual rig with the veteran roughnecks who understand the physical realities of the work.
You have to know the problem intimately.
Furthermore, you need to be physically present to build trust with the local oil capital, the family offices and executives who are funding the seed rounds.
Okay, so the local domain expertise and the money are anchored in the duplex. But the people actually writing the code.
They could be anywhere.
The blueprint explicitly states they can tap world-class engineering, UI/UX design, and machine learning research talent from Austin, San Francisco, Eastern Europe, India, or Latin America.
A hyperlean hybrid model.
Exactly. If you need a senior computer vision specialist to finalize the drone targeting software for the cactus harvest, you do not need to convince them to uproot their family and move to the West Texas desert.
No.
You just need their output via a gigabit connection.
And that output is heavily magnified by the technological infrastructure housed inside the duplex itself. The document mentions the duplex being equipped with powerful local compute resources and, crucially, agentic AI environments.
Okay, I want to spend some real time on that term, agentic AI, because the source material leans on it heavily, and it is a massive leap beyond the chatbots we were used to a few years ago.
It's a completely different paradigm.
How does an agentic AI system fundamentally change the math for a small team sitting in a duplex?
Well, to understand the shift, you have to look at how humans interact with traditional large language models.
Like prompt and response.
Right. If you ask a standard LLM to write a piece of code for a VR headset, it'll output a block of text. You then have to copy that code, paste it into your development environment, compile it, realize it has errors, copy the error logs, feed them back into the LLM, and ask it to fix them.
It requires constant human babysitting. It is essentially a really fast, really smart intern that still requires a manager to review every single task.
Exactly. An agentic AI, however, is not just a tool. It is an autonomous worker. You don't just give it a single prompt and wait.
Right, like you're not just asking it to draft an email.
Exactly. You give it a broad goal, a budget of compute power, and access to the necessary software environments.
So you basically hand it the keys to the car.
Pretty much. You tell the agent, hey, build a physics simulation module for the AR safety app, one that models the trajectory of a high-pressure valve blowout.
And it just knows how to do that.
Well, you give it the SDK for the headset. You say, do not stop until the code compiles without errors and passes these specific safety benchmarks.
And the AI just does it. It writes the code, spins up a virtual machine, tests its own code, sees the failure, rewrites it, and iterates hundreds of times in the background while the human founders are in the kitchen of the duplex making coffee.
Precisely. It fundamentally decouples software generation from human headcount. A team of 3 domain experts in a duplex, armed with a suite of agentic AI environments, can rapidly prototype complex software systems, like the VR simulations or the agricultural data models, at a speed and scale that previously required a team of 50 mid-level engineers.
Because the AI agents are doing the heavy lifting of the coding infrastructure.
Yes.
So what does this all mean? It completely redefines capital efficiency. You are minimizing your burn rate to almost zero. No commercial real estate leases, no massive payrolls, no ping pong tables or kombucha on tap to lure tech talent.
It's a total rejection of the Silicon Valley model.
It is deeply rooted in West Texas pragmatism. Success isn't measured in square footage, but in prototypes shipped. The duplex is just a hyper-efficient machine for turning local capital and local expertise into global prototypes.
And the incubator isn't operating in a vacuum either. The blueprint outlines how the duplex serves as the hub for essential pipelines. They partner with local academic institutions like Texas Tech University in nearby Lubbock to create a steady stream of interns and localized research talent.
And more importantly, the capital pipeline. They host demo days right there in the living room of the duplex. They bring in the Permian oil and gas investors, the wealthy wildcatters, the landowners who are sitting on generational wealth.
Right.
And they pitch them on funding these high-risk, high-reward tech ventures.
Which raises an important question. I am curious how you interpret that specific cultural collision.
The collision.
Yeah. You have West Texas oil money, wealth built on hard physical assets, mineral rights and physical extraction, suddenly being asked to invest in intangible software, AI agents, and virtual reality.
Oh, it's a massive paradigm shift. An oil investor wants to see a geological survey and a drill bit in the ground. They understand that risk. Asking them to fund a virtual reality app requires a translation layer. And that is exactly why the duplex works. Because the founders aren't 22-year-old app developers from Stanford speaking in tech jargon. They are local veterans who can look the investor in the eye and say, remember when that rig blew out in Pecos last year and cost you $20 million in liability? This code stops that from ever happening again.
They are speaking the language of local pain points. It bridges the gap between old world capital and new world technology.
If you are listening to this right now, especially if you manage a remote team or run a business, think about what this duplex model means for you. Are you paying premium commercial rent in a major city simply for the prestige of the address? Are you limiting your talent pool to people who can physically commute to your office?
Right, it makes you reevaluate everything.
The Midland Blueprint argues that with enterprise-grade internet and AI tools, physical geography is no longer a barrier to building world-class technology. In fact, being away from the echo chamber of Silicon Valley might actually be an advantage.
The barriers to entry have shifted entirely. It used to be that you needed to be in a tech hub to access the talent to write the software. Now the software writes itself.
So what's the new barrier?
The new barriers to entry are domain expertise, actually understanding the hard, brutal, physical problems of the real world, and access to patient, substantial capital. Midland has both of those in absolute abundance.
It really is the ultimate start lean philosophy applied to the heaviest of heavy industries. But to fully understand the ambition of this duplex and these tech projects, we need to look at the broader context of the source material.
We had to zoom out.
Exactly. Paramendra's blog post doesn't exist in isolation. The Netizen website features a sidebar filled with timestamps, news headlines, and links to the author's other works.
The meta text of the blog is crucial. It acts as a barometer, giving us the macroeconomic and technological weather report for June 2026. And the weather it describes is highly turbulent and accelerating at a breakneck pace.
Let's look at some of these specific details from the sidebar because they paint a wild picture. The first headline that jumps out is about OpenAI. It says they have confidentially filed for an IPO.
Leading a rush of AI companies to Wall Street.
Right. What does that signal?
That signals the complete maturation and institutionalization of the AI industry. It is no longer a niche research project. It is the foundational infrastructure of the global public markets.
Then there is a headline about Apple's software ecosystem. It notes that iOS 27 has launched, and incredibly, developers have managed to boot Asahi Linux, an open-source operating system, off Apple Silicon using a macOS 27 beta. Why would the author include that deeply technical detail in the sidebar?
Well, it points to the breakdown of hardware monopolies. When you can run open-source, server-grade operating systems like Linux natively on consumer mobile silicon, it means the computing power of a massive data center is now democratized and sitting in the pockets of everyday users.
The compute constraints that used to limit small startups are entirely gone.
Entirely.
Speaking of democratization, there is another headline about global connectivity. NordVPN has launched a service called Saley, offering an eSIM with a United States phone number for $1 a month.
That destroys the friction of global collaboration. An engineer in a developing nation can instantly acquire a U.S.-based digital identity and seamless connectivity for the cost of a cup of coffee.
Allowing them to integrate directly into the workflows of the Midland duplex without any geographical hurdles.
Exactly.
And the final major headline notes that the European Union has ordered Meta to restore free access to AI rivals inside the WhatsApp ecosystem.
Regulatory bodies are aggressively forcing interoperability. They are refusing to let massive tech conglomerates wall off their users from competing AI agents. It ensures that the digital playing field remains violently competitive and open.
So we have an environment where AI is going public, compute power is infinite, and in your pocket, global connectivity is essentially free, and software ecosystems are being forced open. This is a world of absolute acceleration.
And this mindset is reflected deeply in the titles of the author's other books listed in the sidebar.
Right. Paramendra is incredibly prolific, and the titles are uniquely evocative of this specific worldview.
The bibliography is a roadmap to the author's economic philosophy.
We see a title, The Speed Builders, How Humanity Can Deliver Mega Projects in Months, Not Decades. There is Physical AWS, How the Logistics Cloud Will Reshape Global Commerce and Ignite the Age of Abundance.
And then there are 2 books focused on corporate scale.
Let me find them. 1,000 Solaras in 10 years. And From Unicorn to Solara, Building trillion-dollar companies that transform humanity.
The terminology there is very deliberate. For the last decade, the ultimate goal of the tech world was to build a unicorn, a startup valued at $1 billion.
Right, everyone wanted a unicorn.
But the author is discarding that metric entirely. They are proposing a new standard, the Solara, a company valued at $1 trillion.
And the author believes we are on the verge of creating 1,000 of these trillion-dollar companies in a single decade.
It sounds like pure hyperbole, I know.
It really does, until you look at the phrase that appears repeatedly across the author's work, the age of abundance. The blueprint is fundamentally grounded in a concept the author calls calcism, which is described in one of the book titles as the economic and spiritual blueprint for an age of abundance.
Right.
I want to unpack this because calcism and age of abundance can sound a bit esoteric or utopian. What is the actual economic theory driving this?
The core economic theory of abundance argues that the defining characteristic of the digital age is the collapse of marginal costs.
Collapse of marginal costs. Explain that.
If I build a physical chair, every new chair I sell requires more wood, more labor, and more shipping costs.
Sure.
But if I write a piece of software or train an AI model, the cost to distribute that software to the first user is the exact same as distributing it to the 1 billionth user. The marginal cost is essentially zero.
And as AI agents get better, the cost of actually creating the software also trends towards zero.
Exactly. When intelligence, coding, and digital distribution become virtually free, it generates a massive surplus of global wealth. The age of abundance is the hypothesis that this technological deflation will allow humanity to solve foundational problems like energy scarcity, disease, and resource allocation at a speed and scale previously thought impossible.
So if we tie this overarching philosophy back to the dirt and heat of West Texas, why does the Midland blueprint make sense in the age of abundance?
Good question.
Because if software is essentially free and an AI can write a new app in 10 seconds, doesn't that mean the tech bubble is going to burst? If anyone can build software, how does a duplex in Midland create a trillion-dollar Solara?
That is the crucial insight of the entire document. Because software has become a cheap commodity, simply having a clever idea for a digital app is no longer valuable. The value has migrated.
Where'd it go?
In 2026, the only way to build massive, defensible value is to combine that cheap, abundant digital intelligence with incredibly hard, unforgiving physical world problems.
The AI might be a genius, but it has no hands.
Precisely. An agentic AI can write perfect code, but it does not know how to drill 2 miles into shale rock. It does not know what 110-degree ambient heat mixed with blowing sand does to the delicate joints of a robotic arm. It cannot negotiate the water rights for 100,000 acres of desert.
But the people in Midland can. The veteran roughnecks, the petroleum engineers, the desert agronomists, they possess the hard-won, physical world domain expertise of surviving and extracting value from a brutal environment.
And that expertise is the ultimate moat. It cannot be downloaded or generated by an algorithm.
So the strategy is...
The Midland strategy is to take that irreplaceable physical expertise and supercharge it with the cheap, globally distributed AI tools running out of that duplex. They're taking the digital revolution and finally applying it to the heavy atoms of the real world. That is how you build a trillion-dollar company. That is how you build a Solara.
It is a stunning synthesis. They are effectively saying, Silicon Valley solved the software problem for us. Now, we're going to take their cheap software, marry it to our massive piles of oil capital, and use it to solve the physical world.
When you look at the totality of what we have discussed today, the immersive VR safety platforms, the AI-driven precision cactus farms, the ruthlessly lean duplex incubators, all set against the backdrop of the age of abundance, you realize this blueprint is executing a very specific historical model.
What model is that?
We might call it the Gulf Nation playbook.
Ah, okay. Expanding on that, you mean like how regions in the Middle East like Dubai or Abu Dhabi recognized that their oil reserves were finite?
Yes.
So they aggressively deployed capital generated by that oil to build massive logistics hubs, global airlines, and tourism empires. They used the old wealth to buy their way into the new economy before the old economy collapsed.
Yes, it is the deliberate, strategic recycling of legacy wealth. Midland is taking the immense capital generated by carbon extraction, the industry that defined the 20th century, and using it to fund the intellectual property of the 21st century.
Climate-resilient agriculture, autonomous industrial safety, globally distributed tech infrastructure.
They're forcing the old system to incubate the new system.
So I want to turn this directly to you, the listener. Take a hard look at your own industry, your own business, or your own career path. What are the harsh conditions you operate in? What are the expensive, dangerous, or frustrating problems you deal with every single day?
The things you currently view as massive liabilities.
Right. Sunk costs or just the worst part of your job?
The shift in perspective this blueprint demands is to stop viewing those constraints as limitations and start viewing them as a crucible for innovation.
Exactly. What if the solution to those exact problems is actually your most valuable exportable product? What if the thing you hate dealing with locally is the exact thing the rest of the world will pay a premium for you to solve for them globally?
It requires an intellectual pivot. You must realize that your proximity to the problem is your greatest competitive advantage, provided you have the vision to build the solution.
And as we wrap up, I want to leave you with one final provocative thought to mull over. Something building on the wild ambitions of Paramendra's 2026 blueprint. The author is fiercely advocating for the use of old oil capital to fund cutting-edge, climate-resilient technology, robotics, and green biofuels. It is a beautiful model of diversification.
But it carries an inherent tension.
It absolutely does.
Yeah.
Let's play this scenario out to its logical conclusion. Imagine the Midland tech incubator succeeds beyond its wildest dreams. The AI safety licensing becomes a global standard used in every mine and factory on Earth.
The robotic cactus farms scale up.
Right. And the biofuel operations become massively profitable, providing cheap green energy across the Southwest. What happens a decade later when those diversification projects, the software, the robotics, the green energy, eventually become more profitable, more globally critical, and more culturally dominant than the legacy oil fields that funded them in the first place?
You reach an inflection point where the power dynamic flips entirely.
Right. Does the local culture embrace the new identity, or does the legacy oil industry recognize that it has accidentally funded its own obsolescence and try to shut the tech ecosystem down? If you use the resources of the old world to build a better new world, well, eventually the new world might decide it doesn't need the old one anymore.
It is the ultimate paradox of successful diversification. When the life raft becomes bigger and better than the sinking ship, what do you do with the ship?
That is the billion-dollar, or rather the trillion-dollar Solara question for the future of the Permian Basin. Thanks for joining us on this incredibly deep dive into the 2026 blueprint. Keep looking at your liabilities, and we will see you next time.